Okay, in this video, we are going to look at the data analysis for our hydrogen peroxide and potassium permanganate lab. So I already have written up here all the information that we have collected from trial 3. So our molarity of KMNO4 was 0.020. The starting volume was 6.85 and 7.80. The difference was 0.95 milliliters, and we added 1 milliliter of hydrogen peroxide. Okay, our goal, I'm going to write our goal all the way down here. Our goal is to get grams of actual H2O2 over grams theoretical of H2O2. And that theoretical is the 3% based off of the bottle, and then times 100 is going to give me the actual percent of hydrogen peroxide in the drugstore bottle of hydrogen peroxide that we have, okay? So if I'm looking at what I need to figure out how much grams of hydrogen peroxide I started with, and I need to figure out how much I actually have based off of the titration. Okay? We also need to remember one other piece is we have a balanced chemical reaction. So our balanced chemical, is this right here. Sorry. MNO, I should have had this written before I started, but I don't, so aqueous plus 4 waters. Okay? So since I have a relationship between the permanganate and the hydrogen that was in the water, we can go from one to the other and use this to figure out grams of H2O. Okay? But the first thing I need to do is convert this potassium permanganate into moles. Okay? So let's refresh our memory here. So moles is equal, molarity is equal to moles over liters, right? So there's a couple of things I have. I have the molarity, and I have liters, okay? I don't have liters yet, but I can turn it into liters. So we can go 1, 2, 3. So I actually have 0.00095 liters of potassium permanganate that I used, okay? And then I can solve for moles. So moles is equal to the molarity times liters. So the molarity that I have is 0.020 molar times the 0.00095 liters, okay? So if I plug this into my calculator, I should get a really tiny number, 0.02 times 0.0005. I'm going to turn this into scientific notation. It is 1.9 times 10 to the negative fifth. And since this is only 2 significant figures, that's what I'm going to pull, 2 significant figures. Okay? So this is moles of MnO4. So now I can go from moles of MnO4 to moles of H+, and then I can go to grams of hydrogen peroxide. So I'm going to say question mark grams of H2O2 is equal to the 1.9 times 10 to the negative fifth moles of KMNO4. Okay, this color's right now. All right, so then I'm going to go for every 1 mole of the MnO4, I have 8 moles of H+, and then I'm going to keep going. For every 1 mole, this is the hydrogen peroxide of H2O2. I'm going to have the mass of hydrogen peroxide is 34.01 grams. Okay? So then the actual amount of H2O I have here is times 801 is this right here is 5.2 grams of H2O2. Okay, so we have this. We need to figure this out, okay? And that's the easy part, right? So 1 milliliter of H2O, you're like, well, I have milliliters, what I start with. How do I get to grams? We can use density, okay? Okay, so we're going to assume that density is 1.00 grams per milliliter, okay? And then we can just convert. But ultimately, 1 times 1 is 1, so we're just end up with 1 gram, but let's do the math. Okay, so for every 1 gram, I have 1 milliliter, so I have 1 milliliter, or I'm sorry, 1 gram. So then I'm going to come over here, so I have 5.2. This down here is 1.0 grams. So then if I do this math, I'm doing 5.2 grams divided by 1.0 grams times 100 gives me 5.2 divided by 1, nope, 5.2 divided by 1 times 100. I get, something's not right. What did I mess up? That 5 point, I forgot the times 10 to the, on the 5.2. So let me come back here. So 1.9, sorry, I just made a mistake. This should not be 5.2. It should be like 5.2 times something. It should be a smaller number. So I'm going to do it again. 1.9 to the negative 5th times 8 times 34.01. And I'm exactly right. It's actually 5.2 times 10 to the negative 3rd. Okay, so let's try this again. Sorry about that. Okay, divided by 1 times 100. I should get 0.52%, and that was the H2O2 inside of the drugstore hydrogen peroxide bottle that we got. It said that it should have been 3%. It wasn't 3%, so we have to calculate percent error off of this. And chances are the hydrogen peroxide is pretty old, so you can say something about shelf life with the hydrogen peroxide for error. So you're going to do the other 2 trials. If you find out that one of the trials is an outlier, hint, hint, maybe trial 1 is an outlier, you're going to omit it from your average, and then you can calculate a percent error. Thanks, y'all.